May the force be with you. Hello, welcome to a new Science Lab weekly video. Yes, this time we are going to use the force. In science, we call force any interaction that, if unopposed, changes the motion of an object. A force can make an object with mass change its speed, even start moving from resting state, or stop if it was already moving. We call this change in the speed of an object acceleration. A force can also be intuitively described as a push or pull. However, it seems that objects have a tendency to keep their speed constant, no matter what its value is. This also includes changes in the direction of motion. We call this resistance of any object to change its speed or direction of motion, in scientific jargon, inertia. Therefore, when moving, objects tend to do so as far as possible in a straight line and at a constant speed as long as there are no forces acting on them. The word inertia comes from Latin language iners, which means inert, lazy, idle, sluggish. It is understandable then that this name has been given to it specifically for refusing to move when one is at rest. So Isaac Newton defined inertia as his first law of motion in his magnificent book Philosophiae Naturalis Principia Mathematica.
Every body perseveres in its state of being at rest or of moving uniformly straight ahead, except insofar as it is compelled to change its state by forces impressed.
Which basically means
every object stays at rest or stays moving at the same speed unless a force makes it change.
To put these concepts into practice, I propose a very simple experiment in which we will clearly see the effect of forces and inertia. We will need a glass, a card, I used a postcard, and a coin. The idea is to put the card on the glass and place the coin on top of the card. If we remove the card little by little, we see that the coin moves with the card. We must understand that there are several forces at work here. Let's focus on two: the force we apply to the card and the friction between the coin and the card, which is itself another type of force or interaction. The force we are applying is lower than the friction force, so the friction force is still more predominant for the coin, which is pulled with the card. We repeat the experiment, but this time we will remove the card by applying a bigger force, which will result in the card moving much faster. It is important to do this as horizontally as possible. Now the force we applied to the card was bigger than the friction between the card and the coin. This causes the card to slide under the coin, and the coin, due to the effect of its own inertia, stays in position. As the card on which it was resting vanishes, the coin falls into the glass. There are many variations of this experiment, such as the typical scene where the tablecloth is removed from a table full of glasses and plates, and these remain on the table. I do not recommend doing this at home. Seeing this, surely you can think of many examples from everyday life in which we can clearly see the effects of forces and inertia, right? I hope you have learned and enjoyed this activity. See you!